We're asked how many of these three are true. Let's consider the triangle first of all. So it's got the same sides, but all the angles are different. Well, this can't exist because we know this would be an equilateral triangle and all the angles are 60. I suppose you could say, well, how do you know that it's not possible to get other angles? Well, we could draw a line going down like this to split the triangle into two. And actually, we've got two congruent triangles. First of all, this is 90 and this is 90. Because the triangles are congruent, all the angles must be the same. So it kind of disproves, that must be the same as that because it's congruent. It's getting into the idea of congruency, which is beyond what this question is talking about, but it's not going to be possible basically. Quadrilateral is arguably the toughest one. So one possible quadrilateral with four equal sides is a square, but clearly this all has angles of 90, so it can't be that. That only leaves one other shape called a rhombus. And in a rhombus, you actually have these two the same and these two the same. Now, again, how do we know? How do we know there isn't some other shape where all the sides are the same length, but the angles are different? Let's kind of assume they're different. Well, again, we could draw a line going down the middle like this, but then I've necessarily got two isosceles triangles. So that must be the same as that, and then that must be the same as that, but that will necessarily mean that this is the same and this is the same. So I've kind of found a contradiction. It just can't be true because I can, it must be give me an isosceles triangle. So I can rule that one out there. Okay, pentagon is kind of the hardest to actually find one that it's true, but um, it's also like you can see that you can't easily rule it out. We can rule out the triangle and the quadrilateral quite quickly, but we can't the pentagon. And it is the case actually that we can make a pentagon with five equal sides, but different interior angles. So the answer is going to be A. Like I just kind of convinced myself. I thought, you know what, I'm just going to try and kind of draw something, maybe just draw it the same, just try and make the angles are different every time. Um, maybe that goes up. Surely it's going to be possible to not have them all the same. It's not like I can now draw a triangle across and do what I did before. So, you know, I think probably when you're doing this challenge, like you just get an intuitive feel that it is going to be possible to draw a pentagon. Here's one that's given in the answers. And they even comment that it's not like an easy problem to necessarily find these angles, but you could potentially investigate it. But yeah, this is a interesting pentagon, all different angles, but the same sides.